Hello again. Today we want to talk some more about probability distributions, and for this I'm going to make up an example, and you have the luxury of watching this video 2 or 3 times if you find this example complex, but it's really not, and you'll understand that after you see it. So let's just suppose that we've got a club again, and the club has 15 women and 12 men in the club. And we're going to pick 8 to do something. Let's just say to go to Miami. I guess everybody'd like to go to Miami. There's a suspicion that maybe the pick over the years, we do this every year, the pick has not had enough women, that there is some bias here. Whoever's making the selection isn't using a random sample, but they're favoring men in the sample. So we're going to investigate that, and we're going to investigate that with probability. So what we want to do is to we'll let this be x equal the number of women in the sample a better word would have been called group going to Florida. Okay, x is the number of women in the sample. Then what values could x take? It looks like x could be 0, maybe no women in the sample, or 1, or 2, or 3, and I'm going to just put in some dots here, and I could have 8 women in the sample, but no more, because we're only selecting 8 people. So that would be the values that x can take. Now we got to calculate to have a probability distribution. What goes on the right hand side here would be the probability of these values, and we'll just pick one at random. Let's pick this 2 and see if we know enough probability we can reason what that would be. So what's the probability that x is equal to 2? Well, we're going to use the classical definition of probability. So the number of ways that I can pick 8 people to go to Miami, I would have 27 people in the club. That would be 15 plus 12. And we're going to choose 8 of them to go to Miami. So that's the number of ways that we could pick groups of 8 to go to Miami without any regard to gender. Now, how would x be equal to 2? Well, from the set of women, and there are 15 women, I would have to pick 2 people. And from the set of men, and there are 12 men, I would have to pick the remainder, everybody else. And if we're going to get 8, and if I've got 2 women and everybody else is male, then that would have to be 6 males. And this would be a multiplication here. I have to do this thing and this thing. And that would be equal to, this would turn out to be, just using the calculator, 0.0437. We'll check that and verify that in a minute, but that's what I got as I did this quickly, 0.0437. Now, we're not done calculating this probability distribution, because we've got to calculate it for 0 and 1 and 3 and 4 and 5 and 6 and 7 and 8 in order to have the complete probability distribution. Well, we're going to do that, but we're going to do that with the help of Minitab. Now, fortunately, the problem that I've chosen here, and the random variable x, has a distribution that Minitab knows. and it's called a hypergeometric. A hypergeometric probability distribution. And Minitab knows that name, and so it can calculate that easily for us. And I'm going to show you how to use Minitab. So this is an exercise in using Minitab as much as anything. So here I've got a Minitab screen, and we're going to calculate a probability distribution for the number of women in the Florida group. So we know that the values of the random variable, and we said we'd call it X, and so let's just put an X up here for the title of this column. We know that X would take on the values 0 through 8, and so this is a repeat from I guess it was last week or maybe Monday. In any case, we're going to use the calculate, and we're going to make pattern data, and our pattern data is a simple set of numbers, and we want our simple set of numbers stored in this column that we just labeled X, and so that's where we want to store. And we want our first value to be 0, so let's type in a 0 there, and our last value would be 8, and in steps of 1, and each value would be repeated once, and the whole sequence would be repeated once. And so I think we're ready. We'll say OK, and there's our numbers. So again, not such a big set. That would have been easy enough to do by hand, but it is that we've chosen for practice to do it using Minitab. Now here we want the probabilities, and so let's put a label in, and we'll call this the probability of the X's. Now we've got to get Minitab to fill these values in for us, and so I mentioned that Minitab knows this distribution. Let's go to calculate, and we're going to calculate a probability distribution, and these are the list of probability distributions that Minitab knows about, more than we're going to use in this course. But down here, kind of the bottom of the top third, is hypergeometric. And so let's select that. Now we're going to have to fill in some blanks here in order to use this. We're going to get the probability distribution, not the cumulative, but we'll get the cumulative in a minute. The cumulative would be looking for values of X less than or equal to 2. But we want the probabilities. We want X equal to 0, X equal to 1, X equal to 2. So the population size, you know we've checked this radio button, probability. The population size is how many individuals are in the club. And we've got 27 people in the club. The event count in population, that means the thing that we're counting, women, how many of those are there? And there are 15, we said. And what's the sample size? And we said the sample size was 8. We're picking 8 people to go to Florida. So that fills in the stuff about the hypergeometric that Minitab needs to know. The input column is this first column, C1 or W. That's already got a W in it, so I'll just leave it there. I'm going to, it's not W, is it? It's an X. So we'll make that our input column. Our optional storage column, we want that to be the adjacent column, which would be P of W. Or we're not using W right now, we're using X. So P of X would be the storage column. Now take a look at that and see if that all looks okay. We've got 27 people in the club, 15 are women. We're taking samples of size 8. X is the random variable, and its values are in column C1. And we want to put the probabilities in the next column. So I think everything's okay, and faster certainly than what we could. These are the probabilities. Now, we had calculated the probability that x is equal to 2. We had calculated that by hand. And when we did that, we got 0.437. And when Minitab did it, well, of course, it got the same thing. Now, this was easier and quicker than calculating all of these by hand. Minitab is a very useful tool. This is the probability of having no women in the group of 8 if the selection is done at random. This would be the probability of 2 women, exactly 2 women in the group, if the selection is random. You see, that's 0.4. That's pretty small probability. But what about 3 women in the group? Nothing unusual about that. That has a probability of 0.16. That would happen about 16 times out of 100. And 4 and 5, you see, these are pretty probable. Now it starts to get less probable that we would have all 8 women in the group, 0.002, that women would make up all 8 of the people going to Florida. That is not likely if we choose at random. But 4 and 5, those are, as we can see from this table, pretty likely numbers. Now, I said we'd get back to cumulative probability. So let me do this. I'll put this right here for right now. I'm going to title this CUMPROB. Cumulative probability. The cumulative probability at 0 would be the probability that x is less than or equal to 0. Well, it can't be less than 0. So actually that would just be the probability x is equal to 0. It would be the very same as the entry in C2. The entry in C3, row 2, would be the probability that x is less than or equal to 1, which would be the probability x is equal to 0 plus the probability x is equal to 1. And let me do one more of these. I'm going to jump down here to 3. The entry in the cumulative column at 3 would be the probability that x is less than or equal to 3, which would be the sum of the probabilities for 0, 1, 2, and 3. Now, we could get those with a calculator. Since we've got the probabilities, we could just start adding them up. But we don't have to do that. We can go to Calculate, Probability Distributions, Hypergeometric, and we're going to now calculate the cumulative probability, not the probability, but the cum. Population size didn't change. Event count didn't change. Sample size didn't change. The input column is not going to change, but I'm going to store these results in the cumulative probability column. So everything's okay, and there we have it. So these probabilities would be the answers to questions like, what's the probability that the number of women in the sample would be 4 or less? That would be a cumulative probability, and that would be 5.159. So you can see that 4 or less women, that's pretty probable. That's going to happen about 50% of the time. What's the probability that we're going to get 2 or less women? That's not so probable. That's a 0.49. So if you round that to 2 places, it would be a 0.5, but actually it's just a little bit less than 0.5. So we'd consider having 2 or less women in this sample to be pretty unusual. And if when the sample is drawn habitually, we're coming up with 2 or less women in that sample, that's pretty good evidence that the sampling is not really done randomly, that somebody is introducing some bias one way or another. Now, while we've got this probability distribution up here, there are some other things we want to talk about. For example, we want to talk about the mean of the probability distribution and the standard deviation. Now let's flip back over to the graphics tablet and we'll define those things. So the mean of, and actually this would be true for any random variable x, the mean of x, a random variable, is mu. Random variables are about the population, so when we use the word mean for a random variable, the symbol we use is going to be mu, and mu is always calculated as sigma x p of x, and that would be over all the values of x. So if I had everything filled in here, to calculate the mean of x, I would have to extend this column and get an xp of x column, which would just be the products. I mean, 0 times whatever that is would be a 0, and 1 times whatever that is would be whatever it is, and 2 times this would be 14, 7, 8, 0. So this got a little messier than I had intended. I'll just circle that. But this would be an xp of x column, and this would be sigma p of x, and over here, if I got out my calculator and did this, this would be sigma x p of x, which is in fact equal to the mean. Now this sigma p of x, that would always be equal to 1. Of course, if you're using decimals and have rounded, it may turn out to be 0.9987. You know, that would be close enough that we would think the error is just rounding error. But if the sigma p of x turned out to be 3, we would know darn good and well that we had made some really bad computation errors when we calculated the p of x column. So xp of x, add them all up, that gives you mu. Mu is the mean. Now what is the mean? The mean is what happens on the average. So this would be average value of x. Now, without going through, but you certainly can do this on your own now, mu will turn out to be 4.4444 for this experiment. So that means if we keep track over the years of how many women were included in this set, on average, it should be about 4.44. That would be the mean number of women included in that sample. We also can talk about the variance of a random variable. And by definition, the variance, we'll use the Greek symbol again, is sigma squared, and that can be calculated as sigma x squared p of x minus mu squared. So if you need the variance, first calculate the mean, then we could just add a column here to our probability distribution for x squared p of x, add up that column, subtract the square of what you got when you calculated the mean, and you would have sigma squared. That would be the variance. The standard deviation, SD, would be the square root of sigma squared, which we call sigma. Now in this case, sigma is equal to, I've got to look because I don't remember, 1.2016. 1.2016, or about 1.2. That would be the standard deviation of this random variable. Now, how does knowing the mean and the standard deviation help us? Well, we know from earlier work that we did that we would say values between mu minus 2 sigma and mu plus 2 sigma are usual. Now that's just a rule of thumb, but what do we get if we apply that rule of thumb to x? So mu minus 2 sigma for the x would be 4.44 minus 1.2, 1.20 it actually was. So this would be 3.24, and mu plus 2 sigma would be 4.44 plus 1.20 would be equal to 5.64. So now our random variable is discrete. It doesn't take on 3.24, but this tells me values 4 and 5 would be very usual. Those would be very usual values. Now, let's go back to Minitab and just take a second to calculate something like, I don't think we've done this yet, so we're going to calculate the probability that x is less than or equal to 3. I don't remember where we left Minitab. We do have the cumulative. So easy enough. The probability that x is less than or equal to 3 is a 0.212 to round that off. That's the cumulative probability. We could also calculate or think of this as unusually low values. So if the probability of being less than or equal to is a small number that is less than 0.05, then that's an unusually small value of number of women in the sample. So I can see that 2 or less women would be an unusually small number of women because the probability of 2 or less is 0.4. That's less than 0.5. What about for unusually large numbers of women? Let's see if we can calculate that real quick and then we'll end this video. Unusually, let's say lowercase x is unusually large if the probability that x is greater than or equal to x is less than 0.05. Now, I just think this is good practice. You know this, but let's just think about it. Let's look at the probability that x is greater than or equal to 7 to check and see if 7 is unusually large. This would be the probability. Let me erase that. This would be 1 minus the probability that x is less than 7. But x is discrete, and so if x is less than 7, well then x must be less than or equal to 6. What is the probability x is less than or equal to 6? Well, lucky for us, we've got the cumulative probability distribution. So here I find 6, and I see that that is 96232. is the probability x is less than or equal to 6. 96232.96232 is equal to, let's see, this would be 8, 6, 7, 8, 6, 7, 3, 0. Seems that, oh, because Minitab gave me more decimals than what I'm used to working with. This is less than 0.05, and therefore 7 is unusually large. Okay, because of time, this is where we're going to cut this off. We'll take this up when we get together on Wednesday. And meanwhile, watch the video, look for problems posted in Eraser, and have a good day.